Okay, welcome everyone. This is the week one webinar for the online statistics class. Unlike the orientation webinar, this is going to be all about statistics and all about, the ideas of statistics. Although it is the first one, so it's going to be the beginning. And what we're going to be talking about today is always, for all the webinars, by the way, please post in the chat box or ask if you have any questions or comments. And I always have one eye on that, so I'll be happy to answer any questions you have. And then we're going to get into sampling. So that is actually a big deal in terms of how do you collect a sample. Okay. For most projects and stuff, you can't ask the entire population. It's usually just way too big, and a lot of people wouldn't even answer. So you take a sample. So then the question is, what are good ways of taking a sample so that you reduce the bias as much as possible? And that's what we're going to be talking about today. We're also going to be, even though this is the name of the class, so it must be important, we're going to be talking about statistics. And there's a whole bunch of statistics that are important. So, for example, the mean, which is called the average, and for those who don't know stats well, the median. There's a bunch more. The standard deviation is going to be a big one, and there's a whole lot more. And we'll talk about the statistics. We'll go over charts, and those are different charts that you might want to use to visualize what the data shows. And you've seen some of them, like you've probably seen a bar chart, maybe a histogram. But there's a lot of other kinds of charts too. We'll talk about stem and leaf plot. We'll talk about box and whiskers. So some others too. Then we'll get into the z-score. Okay, and that is going to be a measurement of how unusual something is. So that's going to be called the z-score, and I'll show you the formula for that and how you find it. We'll also talk about the kind of variables, the different kind of variables that happen after taking a survey. So that is the plan today. And are there any questions at all you might have about the class or anything else? I'm always happy. So you can also put the questions in the chat box if that helps. But yeah, so if you have any questions, please let me know, and I'm here for you. Here for you. Okay, if there aren't any questions, again, feel free to ask questions throughout whenever you have them. It's what these webinars are about. It's not just some video that, because I do have videos on these chapters that are, but then you can't ask questions during the video and get it answered, but you can on these webinars. So that's kind of the point. So let's get into sampling techniques. And one of the things that I told you that I really love about this class is I could just go online. I can find an example of what we're doing in today's news. Okay. And I can do that for just about any day. Okay. So what I'm going to do is I'm going to give you one that I just read today. And I know a lot of you aren't living in Lake Tahoe. So you may not even, know the reference of this, but I'll tell you a little about it, but not all the details. And there was a survey question. And what it asked was,
actually like
do
math. I
you
don't know if you
feel
got math.
like Representative Kiley is properly
So
representing?
you've never taken a class like that.
So that was a survey question, and that was in the Tahoe Daily Tribune, which is we have a few, but it's one of our main news websites, the Tahoe Daily Tribune, and they happen to have one that works real well for our class. Okay, well, 51% of those who answered said yes. They feel like Representative Kiley. And if you don't know, by the way, Kiley is a representative for the Senate. The Congress. So he's for our Congress. So again, if you don't live near Tahoe, he may not be your representative, but he's ours. Okay, 51% said yes. Okay, the sample size was 543. Okay, and I got this from their website. the Tahoe Daily Tribune. So a big question you might have is, do you trust this study? Does this 51%? Can you say that about all the people in Tahoe? That 51% of all people in Tahoe feel like Kylie is properly representing Lake Tahoe. What do you think? You can put in the chat box. They had a sample size of 543, and basically it's on their website. You click the answer, and it collects your answer. What do you think? Do you think this is trustworthy, accurate results? And what we'll call in statistics, is this a representative sample? Is another way of saying that. What do you think? I don't see you popping in the chat box. Okay. All right. So we got one person that says, not everyone has access to it or knows about the poll. Okay. I think it's right that not everyone knows about the poll. Nowadays, not everyone, but almost everyone has internet access, by the way. It's all free, by the way. The Tahoe Daily Tribune. Numbers can be manipulated. So this is just, they asked 543 people. 51% of them said yes. So they didn't manipulate the numbers, but there are lots of questions. Yeah, only people who feel strongly about politics will respond to the survey. That, I think, is a much more accurate issue, is that if you don't feel strongly about politics, you're not going to respond to the survey. And also, a lot of people don't bother responding to any survey. Okay? So there's bias involved in this survey. And one of the main biases of the survey is called voluntary response bias. And that means that because it's whoever decides they want to do it, they're the ones that do it. They volunteer, and they answer the question. So that's called voluntary response bias, and it's a biggie. It's a biggie. So one thing you might think about, and this is important because it may or may not be biased, do you think that people who decide to answer such a survey are more likely to think Kylie is properly representing Lake Tahoe? Or do you think people who answer the survey are going to be much less likely to think that Kylie is properly representing Lake Tahoe? Because if they're not more likely or less likely, then there's no bias on that side because of that. You see that? Does that make sense? Okay. And I don't necessarily know for sure, that's not necessarily statistics, but it's something you think about. Okay. It might be that, people who are more likely to like Kylie are also more likely to go to the Tahoe Daily Tribune and click on the survey. Okay, that's possible. Okay, and then you'd have a bias that would increase this percent higher than the population. I do want to let you know the sample size is 543. You may or may not know, but we have tens of thousands of people who live in Tahoe, like 20 something thousand people living in Lake Tahoe. They asked 543. That may seem like a small sample, but it's actually not that small. And we'll get into that, not this week, but another week. We'll talk about the details of that. Any questions? Any questions about this example? Okay, so here's the next question, which is kind of the big question. Now let's suppose that you really cared. Let's suppose you worked for the Tahoe Daily Tribune and you really cared about not having bias. How might you collect the data if you wanted a representative sample? Because the way they did it originally was just posting it on their website and letting people choose. Any thoughts about how they might want to do that? How they can reduce the bias? Any ideas? Okay, because this is a very important part of statistics, by the way, is how do you reduce bias? Because if you have bias, then you don't have anything. If you have a lot of bias, then you have nothing that is trustworthy and reliable. So you want to have trustworthy and reliable results. Any ideas? Okay. Well, one thing, let me tell you, since I don't see no one putting in it, there's a lot of different things you can do. One thing is you can get rid of the volunteer response bias by instead of just posting it on their website, you could actually ask people and then give them incentives like money to answer their question. And that way there's very little volunteer response bias because almost everyone is going to answer the question. If someone gave you money to answer that question, I bet you'd answer it, right? That would be one. Most of you would, especially if it was pretty much money. That it would be worth it. So that there's lots of ways of doing it. Okay. And then another is say, well, let's make sure that we don't just get Republicans or we don't just get Democrats because Republicans tend to like Kylie and Democrats tend to not like Kylie. Because, by the way, if you don't know, Kylie's a Republican. So then what you would do is you would make sure that in your survey, you answered a representative sample so that the number of Democrats, the percentage of people in your sample who were Democrats was equal to the percentage of the people in Lake Tahoe who were Democrats. And same for Republicans. Any questions on that? Any questions? Yeah, so sometimes on emails, when you click on the link, the poll pops up. And that happens. Okay, but you still don't have to answer it. That's why there's volunteer response. All right, here comes another one. So I read this. This is according to The Hill. Hill was this is more of a national news station instead of a local one. I thought I'd pick a local one and a national one. And here's what it said. The majority of Americans oppose deporting migrants who have not been convicted to El Salvador without due process. Do you think they know that? Do you think The Hill knows that the majority of Americans oppose deporting migrants who have not been convicted to El Salvador without due process? Okay, what do you think? Based on their survey, and their survey, by the way, they asked 1,095 US adults. Okay, so is that enough? How many US adults do you think there are in America? There's hundreds of millions. Yeah, hundreds of millions of US adults. Okay, they asked 1,095. Well, maybe that's not enough. Turns out if they have a representative sample, if it's truly represented, it is enough. So here's what they did, and I copied and pasted. This is what they had. They had, again, 1,095 US adults interviewed between March 28th and April 1st. Like I said, it's pretty new. That's what I love about this class is I can always find new stuff. Okay. Respondents were selected from YouGov's opt-in panel to be representative of adult US citizens. So they did their best to make it a representative sample. Now, here's what they chose in terms of what they considered being representative. They ensured proper weighting by gender, age, race, education, 2024 presidential vote, 2020 election turnout and presidential vote, baseline party identification, and current voter registration status. So what they did is they made sure there wasn't bias due to any of those factors. And the idea is that might be most of the factors that you would worry about bias. Do you agree? There could be others, but those are the biggies. I think they did a really nice job here. Okay. Any questions about this? Any questions? We're going to see in a few weeks what it means to even say that 1,095 is a big enough sample size. It turns out it pretty much is, but we'll talk about that as long as you have a representative sample. But that is not this week. Okay, so let me talk about what they did, and I want to go into the details in general. When you select gender or age or race or, education, any of those different things, and make sure there's no bias based on them, the way you do it is the following. First thing is the name of that technique is called stratified sampling. So it's very important you get this down. Stratified sampling is kind of the most common sampling that is done in trustworthy sampling. And here's what it is. Okay. So it's a step-by-step process. And I want to let you know you must do these steps. Okay. If I ask you to do stratified sampling. Step one is you determine the strata. And the strata could be age, could be gender, it could be income. Um, you want to determine the strata in something that you would worry that if it's kind of have too much of a, not if you don't represent with that strata, then there's probably going to be bias. So you do the best. In our class, because this is elementary stats, for your project, for example, you're going to if you can do stratified sampling, just pick one. Just pick one thing that you think that is important for making sure that you get representative in terms of that piece. So there's no bias in that. Okay, that's step one. Step two, then you research. Yeah, for our class, it's one category. In the real world, you do more. But again, I don't want to make you do like really hard stuff. Does that make sense? So I don't want to be the bad guy. So I want you to show you understand stratified sampling. That's what I care about. Okay. So step two is you research the percent of each group from the population. That often is really easy. When I first taught this class, it was really hard because when I first taught this class, that thing called the internet didn't exist. So it was really hard to find anything like this. Nowadays, you just go online and you just say, hey, what percentage of Americans are, you know, Caucasian? What percentage of Americans are Hispanic? What percentage of Americans are African American, etc. Okay. And in seconds, you can find that out. Okay. There are going to be some examples that are hard, but most of the time it's pretty easy. Online is really easy to find. So you find the percents. Step three is you multiply the percentages by the sample size to determine the quotas. So let's suppose, for example, in California, let's suppose you wanted to do this, this study, and you found out that, and I'm making this up, 38% of Americans are Hispanic. So, and let's suppose you wanted to do a sample size of 1,000 US adults. Then you would take 1,000 times 0.38, which is 380. And then you would make sure that you ended up surveying exactly 380 Hispanic people, Hispanic adults. Okay. If you get 380 and then the next person is Hispanic, you don't even ask the question to that person because you already got your 380. Is that clear? Okay. And same idea for, each of the races that you are considering. Okay. Any questions on that? Okay. Then the last step, step four is then you conduct the survey, making sure that each quota is exactly established, which is what I just said. And what that does is it means that you have no bias based on that strata. So if it was race, you have no racial bias in your survey. You may have other biases, but at least you got rid of that bias as a potential. So what you usually do is you say, what are the biases that might be a problem? And you choose the one that's the worst and you make sure that that's okay. In the real world, you choose a few, but in our class, we're just going to choose one. Any questions on this idea? Okay, and this is done a lot, by the way. This is done a lot. This is real common. There's also a more complicated way of doing what I just said, which I'm not going to get into. because this is not an advanced statistics, this is elementary stats. Okay. So just want to note that there's two main types of variables. One of them is called qualitative, and the other is called quantitative. You've probably heard those words before, but I'm going to define them in case you don't remember. Qualitative means the answer to the survey question is not a number, it's just a word. Some real common ones are yes, no questions. So that might be something like, do you live in Lake Tahoe? That's a word answer. The answer would be yes or no. Another example might be, what is your favorite color? Right? Pop in the chat box what your favorite color is. If you can put it in. Okay, you notice none of you wrote down a number because that would be silly. You wrote down colors, words. So that makes it qualitative. Is that clear? On the other hand, quantitative means that the answer to the survey question is a number. Okay? And there's lots of those, such as, for example, how much do you weigh? Okay? Put in the chat box how much you weigh. And by the way, I don't care if you lie, as long as you do something reasonable. Don't say you weigh 3 million pounds. So how much do you weigh? Okay, notice those who are saying how much they weigh are putting numbers down. They're not writing words down. Is that clear? And that makes it quantitative. There's some English grammar, which is kind of cool that you like, because you've known it since you were a baby, that you never even think about. And if you have a qualitative question, that would be more like what is. If you have a quantitative, it would be how much or how many type of things. So it's important to hear the words. Okay. If you're interested in saying, what percentage of Tahoe people support Kevin Kiley, it sounds like that's a number, but it isn't, because although you want to you found out that 51% support Kevin Kiley, the survey question is, do you support Kevin Kiley? And your answer would be yes or no. It wouldn't be 52. Is that clear? So that's a common mistake that people make, is they think about, well, I want to find out the proportion of people who do something. If you're finding the proportion of people who do something, that is going to be a qualitative survey question. In this class, if you can't get those, decide which is which, it's going to be a disaster for you. So I want to let you know this is a major, major component of the course, because if you choose the wrong one, the whole thing is wrong. So make sure you get that down. So if you have any questions, ask me too. Okay. So just a note, our sample size was 1,000, or their sample size for the survey question that they had up here, the YouGov, was 1,095. And that was about, opposing deporting migrants. And notice that they didn't ask everybody, because they can't get everyone to answer. My guess, I've never had anyone say yes to this one. Say yes if they asked you and you answered the survey question. Say no if they never asked you, or if they asked and you didn't answer. So were you one of the people they asked? Okay, I'm getting everyone saying no. Okay, that's very common, again, because we're talking hundreds of millions of people, and they only asked 1,095. So they're not going to ask everyone. So what we have is we're talking about a sample and not the whole population. That's all they know. We can't know the whole population. We're going to use the sample, it turns out, in this class, not this week, to kind of make estimates or good guesses of the population, but we won't know the population. So you've learned things like average, which in our class we're going to call them the mean, right? Hopefully you've all heard the word average. All right. Well, if we're talking about the average or possibly the proportion is another word. So in this one, um, we're looking at the proportion and they want to find out is a proportion greater than 50%, because that's what a majority means. And they will not ever get the proportion of all Americans. They will only get the proportion of the people they asked. Okay. When you only have some calculated number from the survey, this is very important, then we're going to call it a statistic. So a statistic comes from the sample. On the other hand, for the entire population, not the people just you asked, but the entire population, all hundreds of millions of people, there is a proportion. We don't know what it is, but there is one. And we're going to call that a parameter. Okay. And I want to give you a heads up for this week. This week has a lot of vocabulary, has very little math, but it has a lot of vocabulary. Are you noticing that? A lot of words. Okay. So again, a statistic comes from the sample, parameter comes from the population, and usually call it a census when you can ask everybody. Any questions on this idea? Any questions? Okay, and again, in the real world, when you have a giant population, you can't get the parameter, you only get the statistic. Okay, so let me tell you a bunch of sampling techniques. So here's one that you probably think you know exactly what it is, and it's actually much more complicated than you think, and that is random sampling. So let's see if you can do this. Pick a random number between 1 and 10 and put it in the chat box. All right. So I see a lot of you put in the chat box, and I will tell you something. I don't believe any of you. Do you know what I don't believe? I don't believe you picked a random number. I believe you thought of a number and wrote it and typed it in. Am I right? Did any of you use a random process? Okay, probably not. Okay, do you think it's hard to use a random process? The hint is actually it's really easy nowadays. Used to be harder. Okay. But I will tell you, if all you do is come up with a number that you think is random out of your top of your head, I don't know if any of you are psychology majors, but they've done a lot of studies and we're not capable of that out of our heads. So instead of doing it out of our heads, how do you think you get a random number? If I say get a random number from 1 to 10. What's the way to do it? Yeah, random number generator. So let me show you. Here's our calculator. First one, random number generator. I made it. This was actually really easy. In this case, the low was 1. The high is 10. And I'm going to get a random number. Aha, 1. Should we get another one? 2. Get another one. 1, 7, 10. Okay, do you believe those are random numbers? What do you think? Okay. Yeah, those are random numbers. And I will tell you in this class, trust me. I coded this and I am a computer programmer too, so I know how to make it work. And this really does do random numbers. I can't tell you the details of how I did it because, I mean, you're welcome to, to look at it, but only if you're a computer programmer. But I'll let you know it truly gives you random numbers. So computers are the best way of getting random numbers, and they really do work. You use a random number generator. And when I say computer, smartphones are computers. I don't know if you realize that. If you guys have your smartphone with you, if you just talk in your smartphone, hey, give me a random number from 1 to 10, it'll give you one and that'll work. Does that make sense? It does a good job. Any questions on that idea? Okay, so that's random sampling. What it means is you have to get a whole list of all the possibilities and then have something the computer pick, okay, which could be very difficult to get the list. For example, getting a random person in America, good luck. You're not going to get a list of all people in America. You just can't do it. Does that make sense? Okay, so random sampling is often very difficult to do. Okay, there are some types of random sampling you can do, but usually it's not randomly selecting people. For example, you can easily randomly select a state in America because there's only 50 states, and you just ask the computer, give me a random state. Okay, or a list of states from, in alphabetical order, 1 to 50, and then give me a random number from 1 to 50, and that'll be your state in whatever that corresponds to in alphabetical order. Any questions on that idea? Okay. Then there is what's called simple random sampling. Okay, that's even more intense. And there, the idea is that in a survey, you're not just picking one person to reply. You might have a sample size of 1,000, and you got to get 1,000 different people. And you want to make sure that every group of 1,000 different people is just as likely as every other group of 1,000 different people to answer your survey. Does that make sense? So another one that's very difficult to do. Any questions on random sampling and simple random sampling? Okay, stratified sampling I went over. It was so important I wanted to go over it first. Again, 4 steps: decide on your strata, research the percentage of each type, multiply the percents by the sample size to establish quotas, and then conduct the survey ensuring the given quotas. And if for some reason you can't get that many people to answer, then you did not use stratified sampling. So it's an absolute you have to. Okay, any questions on stratified sampling? Okay, then there's cluster sampling. Cluster sampling is actually really important in education. So let me explain what it is. It means you divide the population into clusters. Clusters, by the way, if you don't know that word, that means groups that represent the population, and then sample every item in each of the clusters that you selected. So let me tell you where this is especially done, and that is if you want to survey students at a college. What do you think the clusters would be? The standard clusters if you're going to be surveying students at a college or a university? Classmen levels, if you mean like seniors versus juniors, those wouldn't be the cluster because they're too big. So, for example, if you did UC Berkeley, and you looked at freshmen, okay, that's going to be like thousands and thousands of freshmen. Okay, majors, same problem actually. Okay, you want each cluster to not be that big, and it especially works well with community colleges. Any ideas? Should I tell you? Classes. Okay, not what class they like the best, just classes. So what you do is you go to the schedule of classes, which is really easy to find online at any college. And then you pick representative classes that seem to represent the populations. You might pick one statistics section, and maybe an art class, maybe a section of an art class, and maybe a section of I don't know, an English class, and maybe a section of a class that is kayaking because that's like totally different. And you make sure it's representative of the population. You pick maybe 5 or 6 classes, and then you go and survey everyone in that class. And the good news is it's really easy to do that because you just go in and you just either ask them or you hand them a piece of paper and you tell them to write down the answer. And they usually do. They don't usually say, no, I'm not going to do that when it's especially if the professor is the one that asks them to do it. Does that make sense? So that's a very common way, especially in that kind of situation. Another one, kind of one that I like is that let's suppose that you want to find out, let's say you want to find out the average height of a pine tree in the Sierra Nevada mountains. Okay. And by the way, there are billions of pine trees in the Sierra Nevada mountains. Okay. We're a big, big forest. But you want that average height, so you want to get a good estimate of it. So you could cluster sample. What do you think the clusters might be? Any thoughts? Yeah, I don't see you jumping in. Acres. Yeah, you do regions, and that's good. That's kind of ambiguous though. But you can literally, you know, write down, get a map of the Sierra Nevadas, and then you put little squares throughout the Sierra Nevadas, which each one is an acre. Okay, in terms of the size of the square. And then you pick representative acres. So some would be kind of higher elevation, some might be steep slope, some might be next to a creek. Does that make sense? And then you might pick, 7 or 8 different acres. And then you go to those 7 or 8 acres, then you measure all the trees in each of those 7 acres. Do you see how that works? And that's something you can feasibly do. Is that clear? Any questions on that idea? Okay, that's cluster sampling. Okay, then there is systematic sampling. Okay, systematic sampling in kind of definition is a sample every nth item in the population. Okay, so that might be, let's suppose you want to find out, let's say you're a manager for a Safeway supermarket and you want to find out how long people spend in your supermarket. Does that make sense? So you're gonna have to watch the person as they get there and watch the person as they leave. Okay. So what you can do is you're gonna say, yeah, maybe in minutes or seconds, it really doesn't matter. That's just quick, easy math. Okay. But probably minutes, given that it's a supermarket. So then what you do is you say, well, I don't have the time to look at everybody. So maybe instead, every 30th person who walks into the Safeway, I'm gonna, I'm gonna have a camera and I'm gonna clock when they enter. I'm gonna watch until they leave and then clock that and then find the minutes. And then 30 more people, and then I clock that next person. And then 30 more people and I clock that person. Does that make sense? And that's called systematic sampling. That can only be done when it's an ordered group. Any questions on that? Okay, and that's pretty good at preventing bias, by the way. Okay, and especially works well for observational studies when you're just observing. One problem if you're doing a survey where you're asking somebody, they may not want to answer your question, so then you got to give them money or something, make them answer. Any questions on systematic sampling? Okay, then there's convenience sampling. Convenience sampling is you collect the data on whatever's easiest. Okay, so I want to let you know about convenience sampling. It's the easiest. Do you know what the problem with convenience sampling is? It's easy, so you're like, oh, I want to do that. What's the problem? Yeah, you have bias. So let me give you an example. Let's suppose I wanted to find out the average height of students that I've had in my classes, right? Sound good? Okay. So maybe I'll just do a little convenience sampling and I'll just look at the first class I ever taught. Sound good? And by the way, I've been teaching for over 30 years. So I could look at the first class I've ever taught. Okay. That'd be convenient, wouldn't it? Do you think there's bias in that? Okay. Any guess on what the average height of the first class I ever taught was? Any thoughts? What's your guess? Okay. So let me tell you something. If I had posted it, maybe one of these days I will on a different set, different quarter. If I had posted it on the three truths, two truths, one untruth, you all would have thought it was a lie. It was 7 feet tall. I bet you would think that was a lie, right? But it was the first class I did. Okay. Any guess on what that class was, by the way? This should be an easy guess, by the way. Yeah, it was a UCLA basketball team. I wasn't even told that it was going to be all basketball students that they were. And boy, were they tall. Okay. So that'd be convenience sampling is my first class, but it would be very biased. Does that make sense? Any questions on convenience sampling? Okay, so now let me get into the next one. I'm going to mention this because this was like I would say the most important survey study that was done in the last 8 years. Any guess on what that was in the world? I didn't do it, by the way, but I definitely read about it. You don't know what that is? Okay, and you may not agree with me, by the way, but I'm pretty sure that a lot of you will. Should I tell you? It was to see if the COVID vaccine worked. Okay, so again, Moderna and Pfizer, they were the first ones. J&J, they did it later. They they had these vaccines and they wanted to find out if they worked or not. Yeah, something medical, but in particular COVID in the last 8 years. Hopefully, you all know that that was kind of the biggie. Okay, if not, then I don't know where you've been. Um, so what they needed to do is they wanted to find out if the vaccine worked. How do you think they could do that? So here's what they did. They did what's called a randomized control study. Okay, and this is real, by the way. You can quote me on this. And what they did is they got many volunteers, many people. Okay. And they put each of their names in a computer. And then they had the computer randomly select half of them. I'm not sure if it was exactly half, but something like that, to be the treatment group. The treatment group in this case were those that got the vaccine, they got the shot, and that shot really was a vaccine. And the other half was the control group. Okay, those got a shot, and it turns out that shot had nothing in it. Okay, but everyone was told they got the shot, and that's called a placebo, exactly. Very important. And then for the next, few months, they kept track of those people and they tested them for COVID to see whether the ones who got the placebo had a higher percentage of them got COVID than the ones that got the real shot. Is that clear? Okay, and that's what they really did, by the way. Okay, for the original study. And any guess on what they found out? Hopefully you all know. I don't see you guessing. Okay. They found out that it worked. that the real shot, those who got the real shot were a lot less likely to get COVID than those that got the placebo. And by the way, even if they got COVID, they were less likely to die or to have really horrible issues. Okay. And they really found that out. And I will tell you, this is one of the ways I use statistics is I wanted to read the research before I got my shot. I read the research. I saw it. I said, yep, they did it right. Then I went and had them give me the shot. Okay. And, you know, I didn't die of COVID. I know none of you did either because you're here. Any questions on that? If you're forced to, that's a whole different thing. But I do recommend reading the research, and especially after taking this class, because then you'll understand the research better and you'll see if they did it right. And if they did it right, then trust them. If they did it wrong, don't trust them. Does that make sense? So if it was just a bunch of volunteers that all got the regular shot, then volunteers often might be different in terms of the way they act and stuff than the non-volunteers. But if everyone gets a shot, but some get a fake shot, a placebo, then you can trust it. Any questions on randomized control studies? It's a really important type. All right, so let's do something just for fun. Okay. And it's the first person who has interest. I want you to write down in the chat box a survey question that we can ask each other, this group. And it has to be quantitative. So the answer better be a number that you're interested in learning about each other. And the first person who writes one down that really is quantitative, then we'll use that one. So put in the chat box. Okay, good. How many siblings do you have? Okay, including yourself, just to make life a little easier. Yeah, let's go. Yeah, including yourself, how many siblings do you have? And now what I want you to do is put in the chat box how many siblings you have. Now comes the hard part because it's scrolling fast. I got to type them all in. So 3, 3, takes a while. 3, 2, 2, 2. 3, 1. Wait, where was I? 3, 2, 2, 2. 3, 1, 2, 3, 3. 5, 3. Okay. By the way, I bet none of you would guess how many siblings I have. Or guess right. You could guess, actually. All of you could guess, but you can't guess right. All right, let me tell you. 4.5. Because I got a step sibling. I call her a half sibling. Yeah, half sibling. Yeah, it is a new world. Okay, so here's what we can do. And this is important to watch me do it. This is not for the project. This is for like homework and stuff. I can copy this, Control C, if you're using the PC. And then I'm going to go back to the calculator menu. And I'm going to go to the one variable statistics calculator. I'm going to go Control V. Notice it says type in the values separated by commas. And let's call this a sample because it's just you answered out of, let's say, all the statistics students at the college. And there's like there's like 200 statistics students at our college, by the way. And then we hit sample standard deviation. Put in the chat box if you can hear me. I just got a note that said Zoom is having problems. Okay, you can hear me. Okay, just want to make sure because I got a warning. Zoom is causing errors. Okay. Froze for a bit. Okay, we're good now. That's the important thing. Hopefully it's still recording. Okay, and then I hit calculate. What I try to do with my calculator, by the way, is I try to make it as easy as possible. Okay, this is much easier than using a handheld calculator. Do you agree? In terms of what I just did? Put in the numbers, hit sample standard deviation, hit calculate. If this were a population, then I'd hit calculate, then I'd do the population standard deviation. And what this is going to give us is many of the statistics that we care about. So the first one is the mean. Okay. By the way, mean does not mean evil. Anyone know anyone remember? I've already said it today, actually. What's the nice word? What's the kind of simple word for mean that you hear a lot? Average. Okay. But in our class, we're going to use mean. And there's different reasons for it, but now I'm just going to say use mean instead of average. Okay. And that's something you have to do. And in this case, it's a sample mean. And I'll just go 2 decimal places. When you're doing it on your assignments, it'll often say at least like 4 decimal places. Make sure you do what it tells you. If it says, at least 4 and you do 7, that's fine. But don't do fewer than it tells you. Okay. So maybe I'll do 2 decimal places, 2.69. So let's put that in. So the mean is equal to 2.69. Any questions on that? The minimum is 1. Hopefully I don't have to explain what minimum means. I'm hoping you all know that word. Okay. That was the person with the fewest number of siblings, including themselves. And you can't have, including yourself, you can't have anything less than 1. Okay, now comes Q1. Q1 is really important. First thing, the letter Q stands for quartile. Okay, so this is called the first quartile, and that is 2. Okay, and what that kind of means is that 25% of those who answered the survey have 2 or fewer siblings, approximately. Okay, I do want to give you a really depressing heads up that just drives me crazy. And that is there is not an agreement on the formula, a national agreement for Q1. So different calculators will give you different answers. So just a note about that. What I want you to do is just understand the idea. So about 25% are 2 or less siblings. Median. Who remembers what median is? That's something you get in probably like 5th grade or something. Anyone remember what median is? I don't see you jumping in. Okay, let me tell you then if you don't remember. The median is if you list all the answers in numerical order from lowest to smallest, smallest to largest, the median is the middle one. Okay, or if there's like an even number of numbers and there could be 2 middle ones, you take the average of the 2 middle ones. And that's what median means. You've seen that before. Okay, let me tell you something about median. Yeah, so if you had 13 responses, there really is one right in the middle. Okay, yeah, it's like the 7th one. Okay, so let me tell you about mean versus median. This is very important. Mean and median are both important, and they're important for kind of different applications. So, for example, let's suppose one of the examples I like giving is you look at the house prices in Lake Tahoe. And I know some of you don't know Lake Tahoe well, but we have expensive houses. Some are really expensive, really expensive, like $40 million. I'm not kidding, by the way. Okay. If you look at the mean, then those super expensive houses are going to make the mean really big. Does that make sense? If you look at the median, those super expensive houses are not going to make the mean so big because it's not going to like pull it. So if you're interested, for example, in what a typical house is like, you probably want to look at the median. Is that clear? And if you're interested instead, the mean would be interested. Let's say you are, you're on the city council and you care about how much money you're getting in taxes from the house taxes. Then you care about the mean because that $40 million house is bringing in a whole lot of money. Does that make sense? So sometimes the mean is more important. Sometimes the median is more important. Really depends on what you're interested in. Any questions on the differences? Okay, the next is Q3. So it's the same Q that we had in Q1, quartile, but now it's a third quartile. Remember, the first quartile meant that around 25% was at or below that. The third quartile means 75% is at or below that, approximately. And again, it's not a perfect calculation. Different calculators give you different answers. Drives me crazy. But I want you to understand the idea. That's the important thing. Any questions on that? Then there is the maximum. I hope you all know that. 5, that was of those who answered. The person with the most number of siblings had 5 siblings. Any questions on that? Okay, the next one's really important. Okay, it's kind of the most important one that you probably don't, that you may not already know, and that's called the standard deviation. Okay, which is around 0.9, so almost 1. What that tells you, it's kind of as an idea, it's kind of like an average distance from the mean. So how far from the mean do our number of siblings going on? Yeah, distance is it could be below or above. That's how distance works, right? And that is a standard deviation. The standard deviation will always be positive, by the way. It could be 0, but that means everyone's exactly the same. Okay, so the standard deviation in this case is around 0.9. So that means that on average, the mean here was about 2.69. If I add 0.9, then that gives me about 3.6. And if I subtract 0.9, that gives me about 1.8. So the question is, do I want you to round the numbers? So the answer is yes. Okay, and again, I mentioned for the assignments, round what they ask you to round. For the regular, computer graded assignments. For things like the discussion posts or for your projects, round to what is the most reasonable. Okay, so for example, nobody that I can imagine would care about this many decimals for the mean. 2.69230769, da 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 da. No one would ever care about all those, right? So that's why, if it's just to what people might care about, maybe about 2.7. Do you see how that works? And that tells you enough. So hopefully that totally makes sense. Okay. So then so nearest hundredth, yeah. So if you care about 2 decimal places, you would do 2.69. That'd be the nearest hundredth. Okay, make sure you use rules of rounding, by the way, that's important. Okay, so remember 5 up, 4 down. Or 4 flat, I guess. So if the next digit is 5 or more, you go up 1. If the next digit is less than 5, you don't change that. That was rounding. Okay, the next is IQR. What that stands for is interquartile range. What that is, the range is 1, and there's actually 2 ways of talking about it. One is as a single number. And what that is, if we take Q3, which is 3, and subtract Q1, that gives you 1. And that is the interquartile range. It's kind of what is the range of the middle 50% of the sample? Do you see how that works? A lot of times you're going to say, instead of just subtracting, you're going to say it's between 2 and 3 because you basically state Q1 and state Q3. And that tells you, if you want to track the middle 50%, then you want to track the people that have between 2 siblings and 3 siblings. Do you see how that works? Any questions on what interquartile range is? Okay, the next is a sample size. And that was 13. That just means that 13 people answered the survey. So that's another easy one. I will let you know that we always use the letter N for that. N for the number of people who answered. You can think of it that way. So the lowercase n, always lowercase. Any questions at all on this? Okay, so would I recommend using this specific calculator? Yeah, for everything you do except the projects, you're required to use this calculator. Okay? So that is a requirement. Don't use any other. And that is one way I stop you from using AI, because AI will not use this calculator. So just a note, I've given you that warning. So very good question. And for example, Q1 and Q3 will be a little different for different calculators. Use this one. Okay. And by the way, if you find any mistakes, let me know. I'm the author, but like I said, I think over 1 million people have used this now. So any mistakes that have happened have already been told to me. So I don't think there's any mistakes left. But there could be, who knows? Maybe 1 million people didn't find any, even though there was one. But let me know if you find any mistakes or if you have suggestions on making it easier. I do my best. Okay. All right, so let's go back. And again, I'm not going to type in all the numbers, but I wanted to let you know. Median. Notice standard deviation is in bold and giant words. How come? Any guess? Yeah, it's the most important, and you must understand it. Okay. I don't care so much about the formula, because let the calculator do it for you, but you have to understand the idea of it. Okay. And it turns out that if you have an approximately bell-shaped curve, which we're going to call a normal distribution, then if you're within one standard deviation, there's a 68% chance of being within one standard deviation. So that's the majority. If you're within 2 standard deviations, 95% chance of being within 2 standard deviations. If you're within 3, that's 99.7%. Okay, very important. Okay, then the next one is a z-score. The formula for the z-score is z equals x minus mu over sigma, where x is the given value, mu is the mean, and sigma is the standard deviation. Okay. Any questions? I've kind of already talked about all this stuff. Okay, so now I'm going to give you another kind of idea application. Let's suppose, and it's not just suppose, but my goal, I want to have most of the students here pass. Sound like a good goal for me? For you, you just want to pass, but I want most of you all to pass, of everybody. Okay, and by the way, passing grade is 70% or higher. Okay, let's suppose that the average score, let's say last quarter when I taught this, was 74%. Am I satisfied? What do you think? If you know the average score, which is the mean, by the way, was 74%. Okay, so it's a trick question. The answer is you don't know. You can't say, yes, I'm satisfied. You can't say, no, I'm not satisfied. Because maybe the average score is 74%. It's possible. What if 51% of the people got a 69% and the others all got A's? Then the average score, yeah, is a passing grade, but more than half failed. or got a D. Do you see that? So the standard deviation is going to help you understand more than just what the mean tells you. So now here's a new question. Let's suppose the average score is 74% and if the standard deviation is 0.02%. Am I satisfied? Okay, now I'm very satisfied because 0.02%, that means just about everybody got a 74%. Just about everyone passed the class. Do you see that? Because I know the standard deviation is really small, it means everyone is like clustered right near that 74%, and that means they're all passing. Do you see that? If you don't know the standard deviation, if the standard deviation is really big, then maybe there's a whole lot of failed students. Is that clear? See how important the standard deviation is? So here is the rule of thumb, which is also called the empirical rule. And that's what I just said a little while ago. If we have a normal distribution, which is bell-shaped, 68% chance within one standard deviation, 95% chance being within two standard deviations, 99.7% chance, which is very likely, is being within three standard deviations. So just to note, and this is important, in our class, if something is more than two standard deviations from the mean, above or below, we call it an outlier. Got it? Outlier means more than two standard deviations above or below the mean. If it's more than three standard deviations above or below the mean, then it's an extreme outlier. Any questions on this definition? Okay, again, use this definition because there's different ways of talking about outliers. This is the definition for our class. And by the way, AI might get it wrong because they might use some other class's definition, but we're using this one. Okay, any questions at all on this? No questions? Okay. So let's look at some charts. Okay, let's look at some charts. So there's a bunch of charts. And I think the best way to kind of see charts is to now I'm going to go to my spreadsheet. And I can even get this data. By the way, for the spreadsheet, the first thing you're going to do is you're going to highlight all the numbers that you see in column A, hit the backspace, and that erases them all so that you can start again. Then what I'm going to do is I'm going to put in this data. 333, 222. Let me read some more. 312, 3353. Any questions on entering the data? All right, so this, what we got now, right away without doing anything, is it shows you a histogram. Any questions on the histogram looking at it? Okay. So again, it's a little complicated in how it chooses these bounds. It's just, this is Google, by the way. It just does it. So we can see one person was between 1 and 1.9, or one person was 1. And then we had 4 people between 1.9 and 2.8, which is really at 2. Then we had 7 people between 2.8 and 3.7, which is 3s. And we had 1 person who was between 4.6 and 5.5, which means a 5 in this case. Any questions on reading the histogram? Okay. Notice from the histogram, you can look at the shape. You can look at the shape, and we have this big top, tall bar. Okay. That is the that's the mode. Mode is the highest bar. And then notice that other than this one person, most of it trails down to the left from that mode. Do you see that? We call that skewed left. So this is skewed left, slightly skewed left. You're never going to get perfect anything, but it is what it is. Any questions on that? Okay, let me also give you, if we go up to stats, and I'm going to go to box plot. This gives what's called the 5-point summary. So it gives 5 important values for our data. So here, this line here, sometimes they'll call it box and whiskers because this is a whisker on the bottom and this is a whisker on the top, and there's a box in the middle. So this bottom is the minimum. Minimum is 1. Then the next is 2. That is Q1, first quartile. Okay, and then this line here, which happens to be at 3, turns out that one's got 2 things. It's a little brighter, and that's both the median and the third quartile in this case. Okay, they were both 3, if you remember. That won't always be true. They won't always be the same, by the way. And then we have this number 5, which is the maximum. So the box plot is a nice way of displaying this 5-point summary. It's also very easy to see that the middle half is between 2 and 3. Any questions on the box plot? Any questions? Okay, let me do another example. This example will not work well for what's called the stem and leaf plot. And the reason is these are all 1-digit numbers. So let me ask you a question that's more likely to be 2-digit numbers. Okay, and again, you don't have to be honest, but don't be like silly. The question is, how old are you? Don't say you're 3 million years old. If you don't want to say how old you are, just make something up that's reasonable. And I'm going to type in the numbers. My guess is I'm the oldest here, but you know. So 28, 18. Just a minute, I gotta get to the chat. 28, 18, 20, 20, 15. 23. 20, 25. Okay, 43. Okay. Hey, I'll put my own in just to, so you don't feel old. 58. Okay. So this gives you data. And now what I'm going to do again, I'm going to kill this box plot. By the way, you can see the histogram. This is, by the way, unimodal. Last one's unimodal too. Unimodal means there's one bar that's the highest. Bimodal means there's 2 bars that are the highest. Uniform means every bar is the same. Okay, so there's all kinds of things. Normal means that it's bell-shaped. So these are all important words, by the way. Then if I go to stats, now I can go to stem and leaf. And this gives a nice picture of the distribution. But what it also does is you can actually get all the data values. On the histogram, if you look at the histogram, we can see there's 6 people between 20 and 30 years old. But from the histogram, you cannot tell me just by looking at the histogram how many people are 25 years old or how many people are 27 years old. All you know is that how many between 20 and 30. Stem and leaf is different. Stem and leaf, what you do is it's like a little T table. You have the stem, in this case it's the 10s, the leaf is the 1s. And by the way, here you'll see S and L left 10 power 1. So that means that the left is going to be the 10s. If you want the left to be hundreds, then you're going to make a 2 instead of a 1 because 10 squared is 100. Okay, but then we have tens or a 1. We have a 5 for the ones. That means one person is 15 years old. One person is 18 years old. 1, 2, 3 people are 20 years old. So we can see from this, by the way, the mode is exactly 20. Whereas from the histogram, you can't tell me the exact mode. Somewhere between 20 and 30 is kind of the region of a mode. But here you can get the exact mode, and you can get all the exact data values by looking at the stem and leaf. Okay, so stem and leaf is really nice for that. Any questions on that? Let me tell you some things the stem and leaf is terrible for. Let's suppose instead of this little survey, let's suppose we surveyed, 300,000 people. Why would the stem and leaf be a disaster if the sample size is 300,000? Yeah, too many numbers. You can't put 300,000 numbers on a computer screen or a piece of paper or whatever. You can't even do a stem and leaf when it's that big. So if the sample size is gigantic, stem and leaf does not work. The other reason why stem and leaf could be bad is just about everyone in the world can read the histogram and understands it. Stem and leaf, a lot of people don't know how to read it. Is that clear? So it requires an audience that has been taught in statistics. Because my guess is some of you had never seen a stem and leaf until right now. Am I right? Some of you might have, or at least have seen them and understood it. Okay. Forgot how to read it, so. Any questions at all on this example? Okay, let's go. And there are a bunch of others. I'm only doing these 3 for now. There's also things like there's a scatter plot. We'll do that much later at the end of this course, by the way. It's chapter 12, almost the end. So we'll do scatter plots. Then there is pie charts. You've all seen pie charts. I figure since you all know what pie charts are, I don't have to explain them. Do you all agree you know what pie charts are? Because that's something you get when you're young. Okay, so there's a lot of others. Okay. Pizza pie chart, yeah. It looks like pizza. Okay, so I'll let you read the book and you'll see some others. Okay. So now let's talk about the z-score a bit. Okay. By the way, my goal is to be around 7:30 to finish for the webinars, regular webinars. Sometimes it's more like 7:45, sometimes it's 7:20. But 7:30 would be, nice. So just let you know how long they usually last. But it's not gonna be exactly 7:30, most likely. All right, so now I know there's some of you that are interested in healthcare as a profession. Give me a yes if you're interested in healthcare as a profession, you might do that, and give me a no if you're not in the chat box. Okay, so we got a lot of yeses, and I typically get a lot of yeses for a stats class. All right, so now let me give you an example, okay? And the cool thing is, this is my brother's expertise. Remember, I have a lot of siblings. Okay, suppose you're in the hospital and are taking care of an infant that was just born. Any guess what my brother's profession is? He's a doctor, but in particular, he delivers babies. Yeah, OBGYN in particular, a baby deliverer. So that's what he does. Okay, and let's suppose that the baby that was just born had a z-score in weight of negative 3.7. What will happen to that child? What are your thoughts if the z-score in weight was negative 3.7? Okay, so a lot of you, some of you might, I don't really know for sure, I don't know weights of babies and what normal babies weigh. But if I'm told the z-score, I know what's going to go on. What do you think is going to happen to that baby if the z-score is negative 3.7? Any thoughts? Okay, not just under the average size, but an extreme outlier. Because remember, more than 3 standard deviations away from the mean is an extreme outlier. If it's a negative z-score, that means you're on the low side, so under the average side, but not just under, extremely below. So if you're the doctor, what's going to happen? Any thoughts? Okay, this is really important in medicine to understand. You can say worried. I'm going to say ICU. Hopefully, if you want to do medicine, then you know what that is. Yeah, intensive care unit. Yeah, that is going to be a tiny, tiny baby that is going to need extensive medical care. Okay, incubation, all kinds of problems. And I'm not a medical doctor, but I know that if you get a z-score of negative 3.7, you got a problem. Okay. Now let's do another example. Let's suppose that the next infant that was born had a z-score of 3.1. Now, what can you think? Triplets 1 pound each? Yeah, that would be like a negative 3.7. Okay, that's also an extreme outlier. So what do you think is going to happen now? Yeah, definitely. Not probably. Definitely need the C-section. That baby is way too big to come out of the uterus easily. So that is going to be a C-section. There's going to be an operation needed, and that has to happen. Is that clear? Okay, now comes the third infant that's just been born. That third infant was born, had a z-score of negative 1.9. Now what can you say? If the z-score is negative 1.9. Yeah, in this case, negative point 1, not 1.9, negative 0.19 is really close to zero, right? Remember, negative 2 would be an outlier. This is even anywhere in that realm of negative 2. This is going to be just a typical average baby. Do you see? Okay. And a little underweight, you probably wouldn't even notice if you picked up the baby. It wouldn't even feel underweight. It would feel very average, but it's really slightly. Does that make sense? So there's a good chance that baby, if weight is everything, then the baby will just be born naturally. Any questions on that? So hopefully you understand how important statistics is. Okay. Okay. So for example, I know you don't take SATs anymore, but if I told you my math SAT score was 795, do you think I did well or not? Okay. You shouldn't have any idea. Okay. I don't think any of you knew what SAT scores were like 40 years ago. But if I told you my Z score for my SAT score in math was about 5.3, what would you say? Yeah, not just above average, one of the top in all of America. You see? Because remember, 3 is an extreme outlier. 5.3 is just out there. Okay. On the other hand, my Z score for English was about zero point 0.2 for my English SAT. What do you think in terms of how I did an average? Yeah, it was just very average, nothing special. Okay. So we all have talents. As you probably could guess, my talent is math. And there's a reason why I major in math and teach math and statistics because that's what I'm good at. English, I can speak English, but my z-score is like very close to zero. Do you see how that works? Ever understand how z-scores work? Okay, not no one is good at English. There are people with Z-scores of, 2.7, and they're super good at English. So definitely not no one is good at English. There are people that are good at English. Okay, so now let me give you the secret word. The secret word for this webinar is bias, because I want you to remember that when you're doing a survey, one of the big goals of the survey is to reduce the bias as much as you can that is feasible. And feasible means sometimes it's just too much money to spend to make the survey happen. Sometimes it takes too much time to make the survey happen, to make the bias go away. But do what you can with your resources to prevent bias in your sampling. And again, we learned about some ways of doing that. Stratified sampling is one way to help prevent bias. Cluster sampling is one. Random sampling is wonderful, but almost always impossible. So there's different ways of preventing bias. So that is a secret word. Now let me go on and talk about a couple things. Next week's webinar will be Monday at 6. Okay. At least I hope so. I wrote it down somewhere. Let me double check. So let's go to discussions. I forgot to adjust it and look, but if I go to modules, I want to show you where to find the webinar dates. And I go to week 2. And it'll say webinar on chapter 3, Monday at 6 p.m. So I was right. It will be Monday at 6. So I want to show you one more thing that's really important that we're going to be using for this entire course. Okay, and that is symbols. Okay, so I want you to be able to understand the symbols. Typing sometimes is very difficult, but understanding is not hard. Okay, so the first one, it has X, and notice there's a little bar on top of the X. That represents a sample mean. Okay, if this is, let's say, an assignment or an exam, and you need to type it out, if you don't know how to do that, it's okay if you just type in XBAR. I'll allow that. If it's for your project and there's symbols, I want you to use the symbols because that's something you can get help on. I'll help you with how to do it. There are ways of doing it. It's hard, but once you're told how to do it, it's not that bad. Any questions on the sample mean and this kind of the symbol here? Okay, then there is this guy. Do you know how to read this symbol here? It's the population mean. And I want to tell you something. This is horrible. It makes me cry today. Like literally. How do you say this thing? Mu. Anyone know it makes me cry? My cat died last night. Literally, I'm crying. I'm really sad. She lived to almost 20. So mew, mew. That's what she said just before she died. It was so sad. So I don't know if you can see, but I have a tear coming down. Um, so, but it means population mean in our class. Okay. I had a hard day today. So please understand. Okay. And then S is called, my kitty's name was Chio. My daughter named her Japanese, by the way. It's a Japanese manga character. Okay. And then S is a sample standard deviation. Okay. It's a sample standard deviation. Whereas this letter, this is also a Greek letter, and this is read sigma, and that is the population standard deviation. Okay. And again, if you don't know how to type it on an exam or on the homework or whatever, you can type in SIGMA, that's fine. Okay. I hope you all know how to type the letter S, so that one you shouldn't need. And you can type MU for mu. Okay. So that's fine. If you type MEW, I'll let it go too. So anyhow, it's important to understand we're going to be using these symbols a lot in this class. Okay. Let me give you a couple more I didn't type in here, but let's type these in. P is the population proportion. Okay, for P for proportion. Now, now you're used to seeing Greek letters. Any guess on why we don't use a Greek letter for population proportion? Anyone know? You all know the Greek letter for P, and that's the hint. Any guess? The Greek letter for P is pi, and that is really confusing. So we don't use that. Instead, we're going to use P as a non-Greek letter to talk about the population proportion, and P with a hat on top of it as a sample proportion. And that's called P hat. Um, I don't know if you saw me do this on Google. You can do it, but I don't expect you to know how to do it for exams and just exercises. Okay, so that is pretty much it for the webinar. It's 7:32, which is, again, my goal is somewhere around 7:30. So we did it about right today. And what I'm going to do is I am going to stop the recording, and then all of a sudden, we're not going to be made public anymore.